Yeah. Salam everyone. Sorry for taking your time during weekends. Okay. Uh, but we still have to continue with the class because we still have a lot of syllabus to cover. Okay. So I cannot just cancel the class just because I have meetings or what or something else. Okay. Okay. Let's just continue our class. By the way, please remember that we will have a quiz. Okay. The details of the quiz is already written on my guru and also uh, in the WhatsApp group. Okay. So the quiz will be on 9th of July from 1 p.m. to 2 p.m. Okay. Okay. Let's continue with our class. Okay. Now we go to the new topic that is integration. Okay, integrations by definition it is actually the area under the curve. So let's say you have here a curve like in this graph here. So the integration of f. So let's say you have let's say you have okay. So let's say you have a curve defined by y is equal to y is equal to f of x. Okay, so if you have integrations of fx, you integrate with respect to dx, and the limits of the integrations is x is from a up to b, then this value will be a number, will be a specific number which is defined by the area under the curve. Okay, which is given in this shaded region. Okay, okay, so there are several ways on finding the area. We can also use approximations. Um, if we don't know on how to integrate the integrals. So let's say you don't know what will be integration of fx dx. We can actually evaluate this value by approximating the area by meshing the area under the curve by several subintervals. Okay, so we divide the area under the curve by um, dividing the area into several sub-interval, which is actually in terms of rectangles. Okay, so in this case, how many rectangles that you have? 1, 2, 3, 4, 5. 5 rectangles, and this one will be 1, 2, 3, 4, 5, maybe more than 10. So, so these approximations of the area under the curve for the second figure here is more accurate than this one. Okay, it is more accurate than this one. It means that in order to get the best approximation for the area under the curve, we have to make sure that the sub-interval that we take, the number of the sub-interval is approaching infinity. Okay, so this n is the number of sub-interval. So sub-intervals, or in this case, it is rectangles. Okay, so if you take the number of the sub-interval n approaching infinity, it will be very close to the actual area under the curve. In other words, this one, this approximation is equal to the integrations of fx dx, where the f is the curve, this curve here. This is y. Y is equal to fx, which is the curve. Okay. Okay, let's look at this example here. So for this one, you have y is equal to x squared. So it is a quadratic function. Okay. So if you want to know the area under the curve, you can actually find the integration of x squared. You integrate from 0 up to 1. In this case, the x is from 0 up to 1. So by integrating, you get x cubed divided by 3, and from 0 up to 1. So the answer will be 1/3. The answer will be 1/3. Okay? But let's say you don't know how to integrate this. So for that case, you have to approximate. Okay? So how do we do that? Okay, so in approximating, let's divide the area under the curve by 4 sub-intervals. Okay, so from 0 up to 1, we have several 4 sub-intervals. Okay, so for the first coordinates here, the x coordinate here will be 0.1. So here will be 0.5, here will be 0.25, and this one will be 0.775. Okay? And then we draw this so that it's define a rectangles. So this is actually a right hand side rectangle. Why I said so? Because the height of the rectangles is by taking the points on the right hand side. Okay, we can also one note, where is it? We can also define okay, define the area or the approximations of the area by using the left hand side of the point. Okay, that one is the right hand side of the point. So for the left hand side, you take this one instead of this one. Okay, so this is the first rectangle, which is 0 area. So the second one will be this one. Okay, the third one will be this one, and the fourth one will be this one. Okay, so this is also possible. Okay, like before, that I've shown before, you have the right hand side points, which is so here will be 0.5, this is 1, and this is 0. Okay, okay, so you take the right hand side point, so the first rectangle will be this one, this will be the second rectangle, and this one will be the third one, this will be the fourth one. Okay, we can also consider this approximation as well as this one. But of course, the real integrations, the exact value of the area, which is integration of fx dx, will be in between this area. Okay, the summation of this area. I may write it as a1, and it is also less than A2. A2 is this one. Okay. And of course, instead of by using left hand point and right hand point, we can also consider the center point. Okay. So this is a quadratic function, y equal to x squared. Okay. So x is equal to 0.5. Here will be 0.25, and this is 0.7. Okay, you consider the center point, which is if this is 0.25, means that the center point will be 0.125. Okay, so you draw the rectangles. Okay, for this one also. Okay, so this one and this one. Okay, so this is by using center point. You have several ways on approximating the area under the curve. Okay. Okay. Now, so AN here is the area under the curve. So here it is written that if you have n equal to 4, like what we have before, the area will be equal to 1 over 4 squared plus 2 over 4 squared plus 3 over 4 squared plus 1 squared. So if you look at this formula, here. Okay, so the formula will be what? The area for the rectangle will be the height multiply with the height of the rectangle multiply with the base. So the base that you have will be the same for all the rectangles because you divide the rectangle by equal rectangles. Okay, you have equal rectangles. So obviously the base for the first rectangle will be 0.25. The second one will be 0.25. The third one will be 0.25, as well as for the fourth one, also 0.25. Okay, so that's why you have 1/4 here. So 1/4 here is defined for the length of the base, which is 0.25. In this case, 0.25 is obviously equal to 1/4. Okay, if you divide the interval into n interval, it will be 1/n. You divide into n sub-interval, it means that the whole length is 1, so you divide with n. Okay, in this case, you divide into 4, so 0 up to 1. The total length will be 1. 1 you divide into 4, that's why you get 1/4. And then what about the height? The height is defined by the function. The function is y is equal to x squared. So if this is 0.25, the height will be 0.25 squared. Okay, for the height of the first rectangles. For the second rectangle, the coordinates of x is 0.5. The height that correspond to 0.5 will be 0.5 squared, because the curve here is y is equal to x squared. It's the same for the third one. The coordinates is 0.75, so 0.75 squared. Okay, and the last one will be the last one will be 1, so 1 squared, which is equal to 1. So that's why you have 1/4 squared plus 2/4 squared, okay, plus 3/4 squared plus 1 squared. So these four numbers are the height of each of the rectangles. And you know that the area of the rectangle will be the height multiplied with the length of the base. So you total up all the numbers for the height and you multiply with the base, which is 1/4. So the answer will be 0.46875. So that is the approximation of the area if we use 4 subinterval. Okay, and this approximation is not so good because for the exact value, we know that the approximation must be close to 0.333 or 1/3 in order to say that the approximation is okay or acceptable. So if we use 4 subinterval, it's still not so close to the exact solution. Okay, so the table 5.12 summarize the area when we use different values of n. So for the first one is n equal to 4, like what we have shown before. Okay, so the value will be 0.46875. Okay, and then if you have 10 number of subinterval or rectangles, you will have 0.385, which is okay. But then if you use greater number of n, it will getting closer to the value of 1/3. So here, if you use n equal to 100,000, the value is quite very close to 1/3. Okay, so that is how you approximate the area under the curve. Okay, any questions? Do you have any questions related to this? Okay, I hope it is clear. Is it clear, or do you think that it's difficult for you to understand? Okay, the antiderivative methods in finding areas. Okay, example 1. For each of the function, find the area A of x between the graph of f and the interval from A up to x. So here the interval is from A up to x. Okay. And somehow A here is defined as -1. Okay, because it is equal to -1 up to x. Okay, and find the derivative A prime of this area function. So fx is equal to 2. So if you have fx is equal to 2, it means that it is a constant function like this one. Okay, you have a horizontal line, and the horizontal line is defined by y is equal to 2, and it will have intersection at y equal to 2. Okay, and then you have here from -1 up to x. Okay, so the length will be x minus -1. So that's why you have x plus 1 will be the total length. So the length of the base will be x plus 1. Okay, so the area for this for this region here will be the area of the rectangles. Okay, so the formula for the rectangles will be what? It will be the base multiplied with the height, right? So x plus 1 here, you multiply with the height. The height will be, from figure 5.18b. Oh, so this is the second one, not the first one. Okay, this one. This is the first one, A. So the height will be x plus 1. You multiply with the height will be 2. The base, the length of the base will be x plus 1. So for the area of the rectangle, it will be the height multiplied with the base. So 2 multiplied with x plus 1. So the area, the area function A of x will be 2x plus 1. Okay, and then if you differentiate this function, the area function, you will get 2. You differentiate 2x plus 2 with respect to x, you will get 2. And that is the function f, which is the curve. So it is this is just validation. Fx is equal to 2 is equal to A prime is just the validation that our area function is correct here. Okay. Okay. The next one will be this figure here, which is a rectangles. Okay. So you have here x up to -1, and then you have a straight line. It's intersect at y equal to 1 as well as x equal to -1. Okay. So the area of the triangle, you know that from the formula, it will be 1/2 multiplied with the length of the base multiplied with the height. Okay, so the height here, since this is x, okay, here will be the y coordinates for corresponds to this coordinate x will be what? Will be x plus 1. Will be x plus 1 because the function is defined by y equal to x plus 1. So if this is x, if this is x, y here will be equal to x plus 1. Okay, so the height will be x plus 1. And this one is -1. The coordinate of here is -1. So the length of the base will be x minus -1. So it will be x plus 1. So from the formula, it will be 1/2 multiplied with x plus 1 multiplied with the height, which is x plus 1. So the area function will be x squared divided by 2 plus x plus 1/2. And if you differentiate this, you will get x plus 1. Okay, x plus 1, which is actually the function of the curve. Okay, the function of the original curve, which is y is equal to x plus 1. Okay, for C, here you have y equal to 2x plus 3. Okay, so the height will be 2x plus 3. Okay, and then you have here x is equal to -1 over here. X is equal to -1 over here. So the area will be defined by the formula of trapezium. Okay, so the area of the trapezium, oops. Okay, the area of the trapezium. The area of the trapezium will be 1/2 multiplied with the height. Okay, the length of the base. Okay, which is x plus 1. Okay, and then you multiply with what? Here you have 2x plus 3. Okay, 2x plus 3. Why do we have here plus 1? Here it is -1. -1 multiply with 2, you get -2. -2 plus 3, it will be 1. So the height for this part here is equal to 1. Okay. So that's why you have 2x plus 3, which is this one. You plus with the height of this part here, which is 1. Okay. And then you multiply with the base of the, the length of the base, which is x plus 1. So the answer will be this one, x squared plus 3x plus 2. And then you differentiate, you get 2x plus 3, okay, which is the function of the curve. Okay, so, and then we go to the indefinite integral. Indefinite integrals means that you don't define the limit of the integrations. So for this case here, there is no limit for the integrations. For that case, you have to write down c plus c. Okay. After you integrate, you should have plus c. So if it is a definite integral, it will be a number. But for the indefinite integral, it will be in terms of function, and then you have to plus with c. Okay? Okay, and then we have here some derivative functions. Like if you differentiate x squared, sorry, x cubed, you will have 3x squared. So equivalent integration formula will be 3x squared. The integration of this will be x cubed plus c. Okay, and if since you already know that derivative of tangent x will be secant squared x, then the integration of secant squared will be tangent plus c. Okay, uh, and these are several integrations formula. It's just the inverse operations of derivative. If you know that the derivative of x is equal to 1, it means that the integration of 1 will be x plus c. Okay, and since you already know that the derivative of sine x is equal to cos x, it means that the integration of cos x will be sine x plus c. It's just the inverse operation of derivative. Okay, if you know how to differentiate, it means that you should already know on how to integrate. Okay, and then we have several formulas regarding integration here. If you have a constant c under the integration sign, so you can always take out the constant c. You can always take out the constant c. And then if you have a summation between function f and g, you can segregate the integrations of f plus integration of g. It's the same as for the subtractions of f and g. You can always segregate so that it is integration of f minus integration of g. But it doesn't work if we have a multiplication and a division. It only works for plus and minus. Okay? Okay, let's look at example 2. Example 2, we have integration of 4 cos x. Okay, so 4 here is a constant. You can always take out the constant 4. So what is left is integration of cos x. Okay, cos x, integrations of cos x will be sine x. So for sine x plus c. Okay, and then for this one, x plus x squared. Okay, so based on this formula, it says that you can segregate. You can split into two integrals. One is integration of x, another is integration of x squared. So you use power rules. Okay, integration of x will be x squared divided by 2. Integration of x squared will be x cubed divided by 3. And then, of course, you have to add plus c because this is the indefinite integral, which is the integral without the upper and the lower limits. Okay. Okay, next, example 3, which is 3x to the power of 6 minus 2x squared plus 7x plus 1. So this is just a polynomial, which is in terms of plus and minus of a power function. Okay, so you can segregate. The 3 is a constant. You can always take it out from the integration sign. Okay, so 3 multiplied with the integration of x to the power of 6 minus 2. 2 is because it is a constant. You can take out from the integration sign. X squared. Okay, x squared is from here. And then you segregate again for this part here. 7x. Okay, and then plus 1. Plus integration of 1 dx. Okay, and then you integrate each of these component. So x to the power of 6 will be x to the power of 7 divided by 7. And you write here the constant 3. Okay, and this one is minus 2x to the power of 3 divided by 3 by using power rules. Okay, so this one is 7x cubed, squared divided by 2, and this one is x divided by 1. So it stays as x and plus c. Okay. Okay, now example 4. For example 4, you have integration of cos x divided by sine squared x. Okay. Okay, it is not so obvious that you can solve this integral. So what we do here is we split this sine squared x so that it's in terms of sine x multiply with sine x. Okay, so the first one will be 1 over sine x, another one will be cos x divided by sine x. So cos x divided by sine x is cot x. Okay, and then the integration of cosecant x, cotangent x based on the table, okay, table 5.2.1, which I've shown before, okay, on the previous page. This one is negative cosecant x, okay, plus c. Okay, so that is how you solve these integrations. Okay, other than that, how are you gonna solve this? Is there any other methods that can help you? What about substitutions? We will learn about substitution later. Okay, we will look at this later on. Okay, next, okay, this is integration by substitution. Okay, for the substitutions, substitutions is the common method in solving integrations because not all functions under the integrations are easy for you to integrate. It could be that you have to manipulate in terms of other function, and this method is called substitution. Substitutions means that you substitute part of the function so that it's defined as a new function. Okay, so let's look at example 1. So evaluate integration of x squared plus 1 to the power of 50 multiply with 2x dx. Okay, if we look at here, you have quite a complicated function between the between the smile bracket. So the smile bracket, the function between the smile bracket is x squared plus 1. So we are interested to define this function here, which is x squared plus 1, to a new function. So let's say you want to define it to u, okay? So let's say you want to define this as u. So u is equal to x squared plus 1. Okay? If you differentiate u with respect to x, you will get 2x. Okay? So in this case, du dx is equal to 2x. You have to manipulate so that dx will be the subject. Okay? So why is that? It's because we want to replace the dx here in terms of u. So if you manipulate so that dx is the subject, it can be written as du divided by 2x. Okay, so dx here is equal to du divided by 2x. So this one can be written as integration of u to the power of 50, okay, multiply with 2x, okay, it stays as 2x, multiply with dx, which is du divided by 2x. Okay, so let's note that you have here 2x and this one as 2x. It can be cancelled out. So the key point in the substitution methods is you have to cancel out all the previous variable. The previous variable is x. You want the new integrals only in terms of u. If it cannot be cancelled out, then you have to use another method. Okay? If it can cancel out, then you can continue the substitutions method. Okay, substitution method. So in this case, it can cancel out. All the variables in terms of x can be cancelled out. So we can proceed in solving these new integrations by using power method. So u to the power of 50, you integrate with respect to u, obviously you will get u to the power of 51 divided by 51 plus c. And later, of course, you have to replace u into x, into variable x again. So u here is x squared plus 1. So it can be written as x squared plus 1 to the power of 51 divided by 51 plus c. Okay? Okay, next, okay, guidelines of U substitution. Look for some composition, okay? If you don't know the meaning of this, you just have to try and error, like what I've done before. You try, let's say u as x squared plus 1 and see if all the variable x can be cancelled out or not. If it can be cancelled out, then continue with the substitution method. If it cannot, then you have to switch to another method. Okay? Okay, then example 2, sine x plus 9, okay, dx, okay. So u here is x plus 9, okay. And then, okay, you replace the u as x plus 9, and your du will be, you differentiate u with respect to x, okay, you will get dx. So here, you replace dx here as du. So what you will have is sine u du. So this integration in terms of u is much simpler for you to integrate as compared to the first one. First one, which is in terms of x, because it is in terms of x plus 9 here. Okay, so this one is much simpler because you know that the integration of sine u will be negative cos u plus c. Okay, and then after that, you have to substitute in terms of x, which is negative cos x plus 9, and then plus c. Okay, for the next example, x minus 8 to the power of 23. Okay, firstly, you substitute u equal to x minus 8. Okay, and then you differentiate. Okay, you differentiate, you get 1. Okay, so it means that if you make dx as the subject, it can be written as du. Okay, so u is equal to x minus 8. Okay, u is equal to x minus 8. It means that your du will be dx. So you replace here dx in terms of du. Okay, and this one is u to the power of 23. Then from here is just power rules. Power rules, which is the integration of this is u to the power of 24 divided by 24 plus c. And then you substitute again in terms of variable x. Then you get x minus 8 to the power of 24 divided by 24. And then of course you have to plus c because this is the indefinite integrals. Okay, example 3. Evaluate cos 5x. Okay, so what will be your u here? What is the possible substitutions for u. So our u will be 5x. Our u will be 5x. Um, so u will be 5x. If you differentiate u with respect to x, you will get du equal to 5 dx. So the dx, if you make dx as the subject, it will be du divided by 5. Okay, so cos u multiply with dx here is du divided by 5. Okay, so 1 over 5 is just a constant. By the previous properties, it can be taken out from the integration. So that's why you have 1 over 5 outside the integration sign. So under the integration sign, it's just cos u du. Okay, you integrate cos u with respect to u, you get sine u, and then you have to plus c. Okay, so after that, you of course have to replace again in terms of x. So 1 over 5 sine 5x plus c. Okay, so that is how you solve the integration by using substitution method. Okay, example 4. Example 4 is integration of dx divided by 1 over 3x minus 8 to the power of 5. Okay, and then obviously you can replace the denominator here. It is in terms of u, which is u is equal to 1 over 3x minus 8. Okay, so if you differentiate u with respect to x, you will get 1 over 3 dx. Okay, and then you mix dx as the subject, you get dx is equal to 3 du. Okay, so that's why you get 3 du here. Okay, from the different sections. And the denominator will be u to the power of 5. U to the power of 5 can be written as u to the power of negative 5. So from this part here, it's just power rules. Power rules for the integration says that the integration of, let's say, x to the power of n will be x to the power of n plus 1 divided by n plus 1. So it will be u to the power of negative 5 plus 1. It gives you negative 4. And then you divide with negative 4. So negative 4. So that's why you get negative 3 divided by 4 here. And then you plus c. Okay? Anyone still do not understand? Anyone? I hope it is clear. It's not so difficult because substitution is the easiest method in solving integration. And I always suggest my students to use or try substitution method first by using try and error. If it can cancel out all the variable of x, then you can continue with the substitution. Okay, if you cannot cancel out all the variable x, then you use other methods. So it is a very important methods, and the first method that I always try, okay, in solving integration. Okay. Okay, next. Secant. Secant 1 over x plus secant squared pi x. So this is plus. So as I said before, for the plus, you can segregate. You can always segregate into two parts. One is dx divided by x. Another is secant squared pi x divided by, multiply with dx. Okay, so the integration of the first part here will be ln absolute value of x. And then the second one here is something that we can apply substitution. For secant squared x, you know, the integration will be tangent of x. Okay, so integration of secant squared x dx will be tangent x. This is something that you already know. But in this case, it is secant squared pi x. Okay, so you have to use substitution, which is the u here is pi x. Okay, u is pi x, so the u will be pi dx. In other words, your dx will be du divided by pi. Okay, so du divided by pi. So that's why you have 1 over pi here. And this one is secant squared u. Okay, secant squared pi x is already equal to u, so secant squared u. And then secant squared u du, from this formula here, it is equal to tangent u plus c. Okay, if you change all the variables in terms of u, you will get integration of secant squared u du is equal to tangent u. Okay, so this one will be 1 over pi tangent u and then plus c. Okay, and then obviously you have to change back to the variable x. So the u here is pi x, so tangent pi x. Okay, here will be tangent pi x, and then you have to plus c. Okay, next example. Evaluate sine squared x cos x dx. Okay, so this is the combination of two trigonometric functions. Okay, we are hoping that when we use substitution, it will cancel out the variable of in terms of cos. Okay, if you let u equal to sine x, then you differentiate. The du dx will be cos x. Or in other words, I always make dx as the subject. Why is that? It's because I want to replace here. So once we get this, you make dx as the subject. So dx is equal to du divided by cos x. Okay, because you want to replace the dx here. Dx in these integrations. So here it is sine squared x, which is u squared. Okay, u squared, and this one you can write cos x. At first you can write cos x, and dx here is du divided by cos x. So the cos x here can cancel out with the cos x here. Okay, so the answer will be u squared du. Okay, so u squared du. Okay, and then this is just power rules. Okay, so u to the power of 3 divided by 3 and then plus c. Okay, and after that you change back to the variable x in terms of variable x, and you get sine cube x divided by 3 plus c. Okay. Okay, next example, example 8. Evaluate integration of e to the power of negative x divided by square root of x. Okay, so you want to let u equal to the square root of x. Okay, so you differentiate u in terms of x. You will get 1 over 2 square root of x. This is just power rules, because square root of x is equal to x to the power of 1/2. This is just power rule. So if you differentiate, it will be 1/2 x to the power of negative 1/2. So that's why you got this one. Okay. And then you write dx as the subject. Always write dx as the subject. Don't write in terms of u as the subject, because you want to replace dx here. Okay. And then you simplify. You simplify everything, you got this one. You got 2e to the power of u du. So you integrate exponent function to the power of ex. If you integrate with respect to x, it will be equal to ex plus c. It will be itself. If you have y equal to ex, if you differentiate dy dx, it will be ex. So you differentiate exponent function, it will be itself. So that's why you integrate EU, it will be EU as well. Okay, so 2 EU plus C. And then you change everything to in terms of x, you get 2 e to the power of negative x plus c. Okay? Okay, now let's go to example 9. Evaluate integration of t to the power of 4. Multiply with the cube root of 3 minus 5t to the power of 5. Okay, so what will be your u here? So your u will be something which is between the small bracket or um, or under the square root or cube root function. So of course, the u that we are interested here is u equal to 3 minus 5t to the power of 5. Okay, so u will be u will be 3 minus 5t to the power of 5. Okay. So you have cube root of 3u. Okay. T to the power of 4 will cancel out. Why is that? It's because you differentiate in terms of u, du with respect to x, you will get negative 25 t to the power of 4. Okay, so t to the power of 4 will cancel out with this one. Okay, cancel out. Okay, so you simplify, you get this one. Okay, and after that, it's just power rules. It's just power rules. Okay, I think you can continue because they are all just the same. You can continue with example 10 here. But it could be that we have some functions under the integral sign that give you less apparent substitutions. Okay, as example 11 here. So for the example 11, you have integration of x squared multiply with the square root of x minus 1. Okay, if you take u equal to x minus 1, your du dx will be 1. You differentiate x minus 1, you will get 1. Okay, so x squared here will be u plus 1. Okay, so I think it's not too easy for you to follow. So if you take u equal to x minus 1, your du dx will be 1. Okay, if you write du dx as the subject, it will be dx. Dx is equal to du. Sorry, dx is equal to du. Okay, and then here the function under the integral sign, if you want to transform to in terms of u, it can be written as what? So u is x minus 1. Okay, so let's write here as x first. X squared multiply with, this is x minus 1. Okay, x which is equal to u. So you have here u to the power of 1/2. And dx here is obviously equal to du. So if you look at these new integrals, it's still in terms of variable x. It's still the combination. It's still in terms of combination of u and x. How we gonna cancel out this x here? We cannot solve unless we get all in terms of u instead of x here. But somehow we know that the u here is equal to x minus 1, which is not difficult for us to manipulate. Okay, so here the integrations, since we have x squared, so u will be, the x will be u plus 1. So obviously, here will be u plus 1. Okay, so u plus 1 squared multiply with u to the power of 1/2 d. Okay, so if you write this, you can what we call it, expand. Sorry, this expression here can be expanded. U plus 1 squared is equal to u squared plus 2u plus 1. Once we get this one, you can multiply with u to the power of 1/2. Okay, so you get what? So u to the power of 1/2, you multiply with the expansion of this one. Okay, then you get u to the power of 2 multiply with u to the power of 1/2. It gives you 5/2. So u to the power of 2 multiply with u to the power of 1/2. So it will be plus. So this one will be equal to u2 plus 1/2. Okay, 2 plus 1/2 is u 5 to the power of 2. So that's why you get u to the power of 5 divided by 2. And then for the second one is 2u multiply with u to the power of 1/2. So it will be 2u to the power of 3 divided by 2. Okay, the third expression will be 1 multiply with the square root of u, then it will give you u to the power of 1/2. Okay, and then obviously this is just power rules. You can just integrate by using power rules. You get u to the power of 7 divided by 2. Okay, divide by 7 divided by 2. And this one. Okay, and obviously you have to substitute back in terms of x and get this one. Okay, I hope it is clear. Any questions regarding this? Anyone still do not understand? Anyone want me to repeat explaining? Okay, clear. Okay, good. Good, Nafatin Auni. I hope everyone will revise this matter if you still do not understand. But of course, you can always ask me. You can ask me to repeat the explanation if it is not clear. Okay. Next one. Example 12. Okay. Example 12. Evaluate square root of. Evaluate integration of cos to the power of 3x. Cos to the power of 3x. Okay. Cos to the power of 3x is actually equal to cos x to the power of 3. Cos squared x is cos x squared. Okay, it is not equal to cos x to the power of 2. It is obviously not equal to cos x to the power of 2, because for this one, x is to the power of 2, not the whole thing cos. Okay, not the whole cos. So they are not equal. So this one also not equal to cos to the power of 2, not equal. Okay. Okay, we split the cos to the power of 3x into two parts. One is cos squared x multiplied with cos x. Okay. And then you know from the trigonometric identity, it is sine squared x plus cos squared x is equal to 1. So it means that if you have cos squared x, it is also can be written as 1 minus sine x based on this trigonometric identity. Okay, so 1 minus sine squared x, and then cos x stays. Okay, now you let u equal to sine x. If you let u equal to sine x, then this one will be 1 minus u squared. Okay, then okay, you write u equal to sine x. Okay, so du dx will be cos x. Right, so our dx will be du divided by cos x. So du divided by cos x. So the cos x cancel out. This cos x cancel. So what stays is 1 minus u squared. Okay, so u minus u to the power of 3 divided by 3 plus c. This is just power rules. And then you substitute u as sine cube. U to the power of 3 as sine cube. Okay, and this is the final answer. Okay, example 13. Evaluate dx divided by a squared plus x squared dx, where a is not equal to 0 is a constant. Okay. I think let's rest for 5 minutes. I think I'm so tired now. Okay, so let's have 5 minutes break. Okay, so let's continue again. So you have here a squared plus x squared. Okay. Before that, I'm sure you already know that the integration of the derivative, the d dx of tangent x is equal to 1 over 1 plus x squared. So this is something that you already know. So it means that the integration of 1 over 1 plus x squared dx, okay, 1 plus x squared is equal to tangent x, okay, because it's just inverse operation. It's just inverse operation. But here, instead of you have 1, you have a squared. Instead of having 1 here, a constant 1, you have a constant a. So you have to manipulate this expression a squared plus 1 so that it will be in terms of 1 plus u squared, a new variable u instead of x. But you must have 1 here, okay, 1 plus u squared. So for that, you have to take out a squared here. You have to factorize a squared. Okay, if you factorize a squared, you will get 1 plus x divided by a squared. So this is when you factorize a squared. Okay, so you will get 1 plus x divided by a squared. So x minus a here is defined by u. So your new function will be x divided by a. So this is your new function. Okay, so that is your u. Okay, so your u will be x divided by a. So if you differentiate, you will get du is equal to dx divided by a. Okay, so du will be dx divided by a. In other words, your dx will be du multiply with a. Okay, so that's why you get a multiply with, here is dx is equal to a du, so that's why you get here a here. Okay, you multiply with a. Okay, and then you can simplify this, you can integrate this, because you already know this one, you already know this function, this integration. So integration of 1 over 1 plus u squared is just the same as this one, because you integrate with respect to u, and this is with respect to x. Here it is x squared, and this is u squared. So the answer will be, sorry, this is arctangent. This is arctangent, not tangent. Integration. D dx of arctangent. So you differentiate arctangent of x is equal to 1 plus x squared, and integration of 1 divided by 1 plus x squared is equal to arctangent. It is not tangent, sorry. So that's why the answer is arctangent of u. And then you change back in terms of x, and then you get this one. Okay. Okay, next one is sigma notation. Sigma means this symbol here. This is called sigma. It looks like S. Sigma, this and this symbol, it looks like S. Sigma, the first alphabet here is S. And then this one, this symbol here, it looks like S. And our integrations is also looks like S. So they are all related. So our integration is actually equal to the sigma of function f. Okay. But whatever it is, we will look at that later. We first have to look at several values of the sigma for some function. Okay. So if you have here sigma of k to the power of 3, k start from 4 up to 8, it will be 4 to the power of 3, sorry, k start from 4. So 4 to the power of 3 plus 5 to the power of 3 plus 6 to the power of 3 plus 7 to the power of 3 plus 8 to the power of 3, because it stopped at 8. Okay, for this one, k start from 1 up to 5, and the function is 2x. So 2 multiply with 1 plus 2 multiply with 2 plus 2 multiply with 3 plus 2 multiply with 4 plus 2 multiply with 5. Okay, and then you sum up everything. Okay, for this one, 2k plus 1. K start from 0. So k start from 0. K is 0 multiply with 2. So it gives you 1. Okay, when k is 1, it give you 2 plus 1. Okay, it give you 3. When k is equal to 2, it will give you 4 plus 1, give you 5. If it is 3, then it will be 7, and so on. Up to when k equal to 5. K equal to 5 will be 11. So that's why the final expression will be 5. And then you sum up all the values. Okay, and this one as well. Okay, so this is how you define a sigma. Sigma notation means that you sum up from the starting point up to the end point of the variable k. Okay. Now let's go to the theorems. C is a constant. C can be taken out from the sigma notation. Okay, if you have plus, okay, you can always segregate. If you have minus, you can always segregate. Not when you have multiplication and division. You cannot segregate, okay? Only for when you have plus and minus, okay? Okay, let's look at this. K multiply with k plus 1. This is multiplication of k and k plus 1. You cannot segregate into two parts. Firstly, you have to expand this function. Expanding, you get k squared plus k. K squared plus k is just plus. It's just summation of two expressions. So you can segregate. Segregate first the sigma of summation of from k1, k is equal to 1 up to 30 for k squared, plus k equal to 1 up to 30 for k. And then for this part here, obviously you can do what we have done it before, but without using that, we can always get the value of k squared, k start from 1 up to 30 by using this formula. It says that for k squared, k start from 1 up to n, the formula will be n multiplied with n plus 1, multiplied with 2n plus 1 divided by 6. In this case, what will be our n? Our n is 30. You can use your calculator here. So the values will be 30 multiply with 31, multiply with 2n, it is 60. 60 plus 1, it is 61. 31 multiply with 60, you divide with 6. Okay? And then for this part here, for the summation of k, it is given by n multiply with n plus 1 divided by 2. Okay, so 30 multiply with 31 divided by 2. Okay, by using this formula. And then you use calculator, you sum up, you get 9920. Okay? Okay, let's look at example 3. For example 3, 3 plus k squared. K start from 1 up to n. Okay? How are you going to solve this? K start from 1 up to n. Expressed in the closed form. 3 plus k to the power of n. If you write this, it can be written as k start from 1. So the first expression will be 4. K equal to 1. 3 plus 1, it is equal to 4 squared. Plus, obviously, k equal to 2, it will give you 5 squared, and so on. Okay? And the n expression will be 3 plus n squared. Okay? And then it means that we are missing some part if you want to continue from 1 squared. So you are missing 1 squared plus 2 squared plus 3 squared. So these are the expression that you are missing. 1 squared plus 2 squared plus 3 squared. So if you start from 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, okay, continue from this one, you have to minus with these 3 expressions because they are not included in these expressions, okay? And then you know that 1 squared plus 2 squared plus 3 squared and so on up to 3 plus n squared is given by k squared. K start from 1 up to 3 plus n. And this part here, if you sum up, it gives you 14. 1 squared plus 2 squared plus 3 squared is equal to 14. And this one here, based on the formula, which is given in this table here, k squared here, it is given by this formula. Okay? So you have here 3 plus n because our endpoint is 3 plus n. So 3 plus n multiply with 4 plus n. Okay. Why 4 plus 1? 4 plus n? Because n plus 1. Okay. N plus 1. If you have 3 plus n, so 1 plus 3 plus n, it gives you 4 plus n. Okay. And then 7 plus 2n. 7 plus 2n, it's because 2n plus 1. Okay. 2 multiply with 3n plus n. Okay. And then you plus 1. And then you get 7 plus 2n. Then you divide with 6. Okay. So this is divide with 6. Okay. And then you minus with 14, which is this part here. So the answer will be this one. Okay. I think that's all for today. We will start again with the definition of the area. I think this is something that I've taught during the first part of our class today. It's just repetition. Okay, like here you have the left endpoints, the right endpoints, and the midpoints. Well, I think I've mentioned this before. You have left endpoints, right endpoints, and the middle. The middle endpoints are also called as centered. So these are the 3 endpoints whenever you want to approximate. Approximate the area under the curve. Okay? And the area under the curve is always can be written in terms of summation. Okay, so the A here is defined as the area, okay, which is equal to the limit. As I mentioned, you can get the best approximation for the area if you divide the area under the curve as several subinterval as long as the subinterval is taken to be very large. The number of the subinterval is a large number. So that's why it's assumed that n here, which is the number of the subinterval, is tends to infinity. It means that you divide this interval into n which is very close to infinity. Okay, and then you have here f of x k star, and delta x is actually this one, delta x here. This is delta. This is called delta. The triangle here is called delta. Delta x here is the length of the subinterval. This is the length of the subinterval. Length of subinterval. And f of xk is the height. This is the height. The height of the rectangles. Oops. This is the height of the rectangles. Okay. K start from 1 up to infinity. So you sum up the area for the first rectangle, the second rectangle, up to the nth rectangle here. And if you assume that the number of the rectangle is very close to infinity, so that we can get the best approximation for the area under the curve. Okay. Okay. And then I think let's look at this part here. Just for 5 minutes before we stop. Okay. You can use left endpoints, the right endpoints, and the middle points. Okay. So this is the formula for the left endpoints. So xk star is equal to xk minus 1. Xk minus 1. Okay. And then for xk, it is xk. So right endpoints. For the middle point, it is 1/2 xk minus 1 plus xk. Xk minus 1 is the left endpoints. Xk is the right endpoints. So you plus the right and the left endpoints, the right point and the left point, and then you take you multiply with 1/2. It means that you will get the middle point. Okay, middle point of between the left and the right point. Okay, the left endpoints is defined as xk. A is our first coordinate. Okay, a plus k minus 1 delta x. Okay, and our xk is a plus k delta x. So if you have here, let's say, like in the previous example, you have a quadratic function. Okay, so our a here is the first coordinate. In the if the area that we consider is from 0 up to 1, okay, our a will be 0. Okay, it's the first one, and our 1 will be b. Okay, this a and b. A is the first limit, and b is the second limit. Okay, this is the lower limits and this is the upper limits. Okay, and then you have k minus 1. Okay, delta x. So for the left endpoints, if our k from 0, okay, if our k start from 0, so our a is 1, if our A is 0, okay, if our A is 0, K start from 0, K start from 0, 0, -1, delta X. I think this is not correct. It should start from 1. If K start from 1, then it is correct. So our first point will be the left endpoints, okay, which is A. If you have K equal to 1, then this is correct. Okay, let's look at the right endpoints. If K is equal to 1, A plus delta X. So our delta X is the length of the subinterval. So this is our delta X. Let's say you divide with 3 delta X, 3 subinterval. So this is delta X, this is delta X as well, this is delta X as well, the length. So for the right points, it will be A plus delta X. A plus delta X, provided that the first one is K equal to 1, not K equal to 0. So this formula is not correct. It should start from 1. Okay? Is it clear? Anyone still not clear about that? If it is clear, then please write clear, okay, so that I can continue happily. And I hope everyone understand this, because it's the basic in the integration. Okay. And for the midpoint, is just 1/2 of the first point plus the second point. Okay, so this is our the formula for the midpoint. Okay, we stop up to that. Okay, we will continue later with example 4. Sorry for taking your weekend time. Okay, so let's end our class today. Okay, so thank you very much. I will stop the recording now, and you can leave the meeting room.